Okay, so we're on to section 14.6, and right before they say what the directional derivative is, they do an example with the chain rule. Yeah, we talked about this in class. We said let's let x be a plus su1 and y be b plus su2. And the quick check said, if you do that and use some unit vector, show that any change delta s in S produces a line segment of length delta S. Okay, well, let's see if we can do that. I guess I kind of want these out of the way. Maybe we could see both. So, as I do 14.6 quick check 2, it says we're going to change some amount delta S. So, okay, x equals a plus su1, right? Y equals b plus su2. So if instead I change S, so replace S with S plus a little bit more. I think that's what they're saying, right? So if I do that, I'll get some other points. Maybe I'll call this X, I'll call this X1 and Y1. Well, maybe I'll call it 2, X2 and Y2, because it's kind of like I start here at X and Y, and then I move to X2 and Y2. So this would be A plus S plus delta S, U1, and this is B plus S plus delta S, U2. Okay. And so we're going to be somewhere else. Where are we going to be? I mean, here's my vector U. It has coordinates U1 and U2. Let me move the book and we can see a little more. So there's U1 and U2 is this vector, right? And so in general, the way it works is you start at AB, and then whatever S is, you move that far along, and along this line. And so what happens if I move a little bit farther, right? Delta S. That's the question. So I guess what happens is, like, maybe this is X1, Y1, which would be AB plus S times that. And then I move delta S and I get to X2, Y2. And you just want to show that, that's a line segment of length delta S. So I think what I would do is, call this X1 and Y1, call that X2 and Y2, and then I would just measure the distance between the points, right? So let's see, the distance formula, and I conveniently labeled them X2 and Y2, so we could use the distance formula, right? It's X2 minus X1 squared plus Y2 minus Y1 squared, right? So that's the distance formula. So what do we get? We get, well, when you take X2 and subtract X1, I guess the only thing left is delta SU1, because the SU1 drops out, the A's drop out. So I have delta SU1, that's being squared. And here I have delta SU2, that's being squared. Right? So we can factor something out. We can factor out delta S squared. And what are we left with? Yep, u1 squared plus u2 squared. So this is equal to the square root of delta S squared times the square root of u1 squared plus u2 squared. By the way, this does not equal u1 plus u2. I was trying to get that across to my algebra class yesterday. Right? But it does equal 1 because this is basically the length of vector u, right? And we said that's a unit vector, so it equals 1. And so this shows you that the answer is indeed delta S. Because delta S is positive. That's it. Right. Is that okay, Kathy? All right. Now there were other questions people had from 14.3.